In this video, we will discuss about the impulse response and transfer function of systems. So the response of a system for an impulse is called impulse response, and we can represent mathematically by using h of t if the signal is time domain signal, or by h of n if the signal is discrete time signals. And we can represent the input output relation using these equations, that y of t is equals to x of t convolution of h of t. And if you see that the system is given an input which is an impulse, and the output of y of t is basically the impulse response of that input. And if you want to write in frequency domain, you can write y of w is equals to x of w multiplied by h of w, where h of w is the ratio of the output to the input. So this is basically known as a system transfer function. If you take the inverse Fourier transform of this equation, then you will end up h of t. You can write the same function using the Laplace transform, and at the end you can take inverse Laplace transform to get back the system impulse response. This is an example where you are given with the response of the system. Y of t is equals to rt plus 3 minus rt plus 2 minus rt minus 2 plus rt minus 3. And it is said that you need to draw the resultant, or you need to draw the response of the system. So you need to basically understand what does that mean. So r basically is the ramp function, and you need to know how we represent the ramp function. If it is a shifted version or if it is a time reversal, then I will start basically from the first step. Like, let's see, the ramp signal is represented by using this graph, and then if it is time reversal, then you can write r of minus t, and you can see it is an image function of the given signal. But if it is minus r of t, then you can write that signal by using this graph on the negative x-axis. But if it is minus r of minus t, then this is the time reversal of that signal. So similarly, we need to draw this first one. So this shows that this is a shifted version. Like, if you equate t plus 3 is equals to 0, then t is equals to minus 3. So it means that the signal will start at t is equals to minus 3 and keep going up to the infinity. The second signal, you can see it is r t plus 2. So where if you equate t plus 2 is equals to 0, the answer is minus 2. So it means that this is a ramp function and shifted version of the ramp function on the negative side, but on the negative side. So you will draw the same signal on the negative side. And if you see the third signal, that is rt minus 2. So if you put t minus 2 is equals to 0, the answer t is equals to 2. So this is the shifted version at 2, but on the negative side because it is minus r. The third one is rt minus 3. So this is again the shifted version where t is equals to 3. So the shifted version at t is equals to 3. And then you can calculate the resultant signal. So if you see from minus t at minus 3 to minus 2, you only have this signal. So that is the ramp signal only. So that is why you will draw just that signal. So from minus 2 to plus 2, so that other signal is there, and similarly the that signal is there. So these two signal cancel each other, and then you will end up with a constant line here. And then from 2 to 3, these two signals cancels each other, but you only have that signal, the third signal. So that is why you will end up with that signal. And then from t to infinity, you have these signal will cancel each other. Similarly, these signal will cancel each other, and the answer is 0. So that is the graphically you have drawn. But if you want to see the same result using the mathematical equation, then we can do that as well. Like, from the first signal is rt plus 3. So yt is equals to t plus 3. From minus 3 to minus 2, you only have t plus 3. And then second, yt is equals to t plus 3 minus t plus 2. t plus 3 minus t plus 2 from minus 2 to 2. So t plus 3 minus t minus 2. So the t will be cancelled with that t. So plus 3 minus 2 is equals to 1. So that you have constant line here at 1. Then minus from 2 to 3. So from 2 to 3. So you have y of t is equals to 1 from previous side, or you can say t plus 3 minus t minus 2 minus t plus 2. So that is minus t plus 3, or you can write minus t of t minus 3. So that is a shifted version at plus 3. And then at last, at bigger than 3, you have minus plus minus 3 plus t minus 3. So plus t minus 3. So they cancel each other and the answer is 0. So these are a few examples. We need to calculate the integration. Like first, from minus 2 to infinity, t plus 2 del t. So we need to calculate the integration with respect to the del t, and del t is the impulse function. We know that we have an impulse signal at 0 is when the value of t is equals to 0. So that is why you can straightforwardly write its integration t plus 1 when t is equals to 0, because everywhere else the signal is 0. So 0 multiplied by anything, the answer is 0. So at t plus 1 only available when the t is equals to 0. So if you insert t is equal to 0, the answer is 1. Similarly, the second one is from minus 2 to minus 6, but you need to integrate with respect to the impulse function. And we know that the impulse function is available when t is equals to 0. But if you see the limits are from minus 2 to minus 6. So it means that the signal is not available at t is equals to 0. So the limits are from minus 2 to minus 6. So that is why if you have only signal from minus 2 to minus 6, but the impulse signal is only at t is equals to 0. So it means that the answer will be 0, because everywhere else the impulse is 0. The impulse is available only at t is equals to 0. So if you multiply this signal with and at any point where t is not equal to 0, the answer will be 0. Third one is that you need to integrate from minus infinity to minus 2 when the function given is e raised to from minus at ut. So ut is the unit step, so which means that the unit step started from 0 to plus infinity. But you can see that the limits from minus infinity to minus 2. So signal is not available from 0 to plus infinity. So that is why again the answer is 0. In this case, the limits are from minus infinity to infinity, and the impulse function is again shifted version at t is equals to 3 on the positive side. So it means that you can write that signal over there, and you can take the integral of e raised to power 3 minus t, whose integral is minus e 3 minus t at t is equals to 3, because we know that we only have signal available at t is equals to 3. So when you insert the value of t is equals to 3, the answer will be equals to minus 1. The responses of the system are given, and it is asked that either the system is stable or unstable. You need to say after looking at the given response. So if a response of the system y of t is equals to x square of t, so then it is asked that either the system having this response is stable or unstable. We usually take the input signal as a unit step signal, as a test signal. So if the input signal is a unit step signal, and you know that squaring the unit step signal will be equals to the unit step signal. So unit step signal is a bounded signal, so that means that the system is stable. Second example is x of t cos omega naught t. So you can see again that the maximum and minimum value of cos is from plus 1 to minus 1, and xt is again a unit step. So if xt is a unit step multiplied by 1, so again the system is a stable system. Third response, y of t is equals to x of t minus 2. So again it is a shifted version. So you can take the unit step as a shifted version. So again the unit step is a stable system. But if you take the integral of the input, and you know that the integral of the unit step is the ramp signal, and so the ramp is unbounded, so which means that the system is unstable. So if you take the derivative of the input signals, derivative of the input signal, if the input signal is unit step, will be the impulse, and you know that the impulse is again unbounded system, so that is why the system is unstable. The last one is a discrete system response. Y of n is equals to x of n plus 2x of n plus 1. So this is again a unit step whose amplitude is 2. So this is again plus unit step whose amplitude is 2 and is shifted at when n is equals to minus 1. So minus 1 you have at the amplitude 2, and then onward you have the amplitude of 4. So again the bounded output. So that is why the system is stable. And it is asked that you need to calculate the integral of sine of 3t minus t with respect to the impulse function at 3t plus 4, where the limit is from minus infinity to infinity. So it is an assignment for you. You need to calculate this question and let me know what is the answer, and then we will see is the answer is right or wrong.